From a thin piece of cardboard 50 inches by 50 inches, let me sketch a square real quick, okay? Hold on. I'll get that perfect square. All right, let's say this is 50 inches on top. And this side is also 50 inches, okay? But what are we doing with this cardboard? We are cutting square corners. Square corners are cut out so that the side can be folded up to make a box. So take a look at what I'm doing over here, okay? So I'm cutting little corners off. Sorry, I want it to be perfect, you know what I mean? Oh, come on, make okay. Make a square, little notepad. All right, so I'll just do it. I'm sorry. Let's stop wasting time. No, I'm gonna try one more time. Yeah, there we go. So, that's how much I want cut off, okay? And I will do this to all four corners. So I'm gonna do this copy. I'll copy this down here. I'll copy this up here. I'll copy this down here. So the red are what you are cutting off. So if you cut this off, that much is gone, right? I will stop shading this. So let's say that we cut X inches off from this end and X inches off from this end. Like it's a square, so you know what I mean. Like these are gonna be X's. And I don't know how much we're cutting off, so I'll just call it X, okay? And then what they're doing is we're gonna fold this up, okay? If you fold this, I'm gonna color this real quick, all right? Hold on. I want you to visualize this real good. So what we have is the red pieces are cut off. So this gray amount, this fat cross looking thing is left. You agree? Just color it inside now. All right. Okay, so you're going to get this fat cross and you're going to fold this. Okay, how are we folding this? Folding this line, folding this line, and this line, and you're gonna fold those up. And if you glue it together, like glue these ends together, okay, ends what I mean by like these. Okay, if you glue this side, it's going to meet which side? Like this side, right? It's going to stand up and become an open box, right? It's gonna look like a pizza box. So that's what they're doing. Okay, the only material they had was that 50 by 50 thin cardboard. And I guess they have glue or, tape. But that's what's happening. They're asking what dimensions will yield a box of maximum volume. What is the maximum volume? Round to the nearest tenth if necessary. So let's talk about the dimensions of a rectangular box or prism, okay? We're gonna have length, width, and height. Length, oh my gosh. Width. Okay. Now, I'm gonna highlight the length of this rectangle here, okay? This green part. You don't see green yet, do you? No, I didn't put it just yet. Right, hold on. This is going to be the length of the rectangle, like this bottom part right there, this green. Okay? You agree this is shorter than 50 inches, right? It's shorter than 50 inches because we cut X from the left and X from the right. So think about this for me. You used to have 50. You used to have 50, but you took X from the left and x from the right. So you took those away. You took how many x's away? 2 x's away. So the length of this rectangular prism is going to be 50 minus 2x. Now look at the other side for me. The width, okay? This dimension. How much do you think that much is? Well, we used to have 52, right? We used to have 50, but we cut off x from the top and x from the bottom. So if you take away 2 x's from it, we're going to have 50 minus 2x left. Now imagine folding this up. How tall do you think this pizza box is going to be? Okay, if you fold this up, the height of the rectangle will be this, right? Or this, okay? That's how tall this will be. So the height of the rectangle is actually just going to be x. That's how much is going to come up. So I'll say height is x. Let's write the volume of this pizza box using these 3 dimensions, length, width, and height. Okay, so volume is equal to length times width times height. Okay, so I'll say V is 50 minus 2x times 50 minus 2x times x, length times width times height. I'm going to multiply this out because I don't want to use product rule, you know what I mean? I'm going to just multiply it out so that I can just do power rule over and over, okay? So here I go. Volume is equal to, I'm going to go ahead and FOIL this. 50 times 50 is 2,500. Okay, next, if I multiply this, that's 100x. This is going to give me another 100x. So they add up to negative 200x. All right, lastly, I do negative 2x times negative 2x. This is going to be plus 4x squared. Now, remember that little x outside? I'm going to multiply this out. I'll FOIL it. I'm sorry, not FOIL. I will distribute it out. I will get 2,500x minus 200x squared plus 4x to the third power. So we got the volume formula in terms of x, and x is how much we are cutting out from each corner, right? So now they want us to find the maximum volume. So let's try to find the maximum, but we need to start with critical value, right? So take the derivative of this volume function. Let's find v prime. So I'll get 2,500 minus 400x plus 12x squared. This is a quadratic, but I do not think this is factorable. So I will set it equal to 0 to solve for it. You don't really have to switch the order, but I'll try to write this in ax squared plus bx plus c form so that you can see what a, b, and c are. Uh-oh, did not mean to put that. 2,500. As you can see, a is 12, b is negative 400, and c is 2,500. Let's solve for x using the quadratic formula. So you're doing negative b plus or minus b squared minus 4ac all over 2a. I'm going to set this up. This is going to be negative of negative 400. That's going to be positive 400 plus or minus square root of negative 400 squared minus 4 times a times c all over 2 times a. So, whoa, okay, I got it set up. Now it's time for us to plug this into the calculator so that we can find 2x values, okay? So what are the x values? I know I'm going to get 2 answers. And I think one of them will be the answer, okay? So I need a calculator to type this in. I'm gonna do a scientific calculator. And type in 400, let me make it a fraction first, 400 plus square root of negative 400 squared minus 4 times 8 times c all over 2 times 12. The first answer is positive 12. If I change that symbol in the middle to negative, I will get 8.333. So I'm going to write those down and we're going to talk about it, okay? 8.33. Now, what did we just found? We just found out something will happen if we cut 25 inches from each end, or 8.33 inches from each end. Now look at the 25 first. Think about the 25. What will happen if I cut off 25 inches from the top and 25 inches from the bottom to build a box? Well, I only have 50 inches. So if I cut off 25 inches from the top and 25 inches from the box, I cut everything off. I do not have anything to fold to make a square. So guess what the volume at that point will be? If I don't have a square, if I don't have a box, do I have a volume? No, the volume will be 0 if I cut off 25. Okay, things will be canceled out. It's going to be 0. So 25 is not going to be an answer because we're looking for a way to maximize volume. We're not looking for a way to have no box, right? So I hope that's making sense. I'm going to cross out 25 because that's going to make no box. But if I cut 8.33 inches, something will happen, right? Now, I'm going to do some work on the side here. So I know something will happen when x is equal to 8.33, okay? This is a critical value. The question that I have is this the value where the maximum or minimum will happen? So what I'm going to do over here is I'm going to perform a little second derivative test. So I'm going to do second derivative test to confirm this. Okay? Because remember, if you plug in an x value into the second derivative, if it comes out to be positive, then we're looking at a minimum point. If it comes out to be positive, then we're looking at I'm sorry, did I say that already? I'll just do this. I'll just do this instead of talking. So I need the second derivative to perform a second derivative test. So I'm going to just grab that first derivative real quick and be like, all right, let's take a derivative. So what is the derivative of, all right, I'm going to go ahead and circle this so that you can just look at that part. I need you to focus on this line and take the derivative of that, okay? Derivative of 2,500 is 0. Derivative of negative 400x is negative 400. And what will happen? If I take the derivative of 12x squared, that's going to give me plus 24x. Now what I'm going to do is plug in 8.33 into the second derivative. What is the sign of the second derivative if 8.33 goes in here? Remember, I just care about the sign of this, okay? So I'm going to plug this in. I need a calculator. Negative 400 plus 224 times 8.33. That comes out to be negative. So I really don't care if that is negative 5,000, negative 200. I just care this is a negative number. Now, if the second derivative is negative, then we're looking at a relative maximum value. Okay, so I think we found what they wanted. So this is our little proof over here. Okay, what I did in this box right there. This is a proof that what I found is actually the relative maximum point, not the minimum point. And I do want you to include that on your bonus. Okay, all right. So what do? Now I need to give them the dimension and the actual maximum volume. I'm gonna copy this dimensions. Okay, I'll copy it down here. Because I know what x is. All I need to do is plug them in here, okay? So let me start with the length, okay? The length is going to be 50 minus 2 times 8.33. I'll set it up. the width is going to be the same, 50 minus 2 times 8.33. And the height I already know. Height is going to be just x, 8.33 inches. Okay, so I'm gonna go plug these 50 minus 2 times 8.33, and I get the length of this rectangle has to be 33.34 inches, and the width is exactly the same, so I'm gonna say 33.34 inches. So we got the dimension over here. Okay, so these are the dimension, so you will have to give me that. These are the dimension of the box. Now let us find the volume. Okay, remember, volume is simply length times width times height, right? And we know what they are. So you're going to do 33.34 times 33.34 times 8.33. And if you multiply these three dimensions, each has inches for unit, you are going to have a unit of cubic inches. Okay, so let's write the final answer. I'm doing 33.34. Oh, these emails, you know, 33.34 times 8.33. So the final answer, the maximum volume we can have is 9,259.26. Write down the correct unit of cubic inches. So that's how you can do this optimization problem. I think it's not bad. I think you can do it. Okay. But really, I want to stress this part about showing me a quick work that why what you found is the maximizing point instead of a relative minimum point. So include the second derivative work for me for this optimization problem. Okay.